that, you know, vertex form, right? So opposite H follow K. We'll review it. Okay, so -3, 0. So I'm going to plot points. So if I have -3, 0, okay, so now if I throw in another point, if I let x be 1, what's 1 plus 3? Oh, wait, no, ignore me. If this is -3, you guys remember this is your axis of symmetry. If I go 1 unit to the right, if that's -3, this is -2. So what is -2 plus 3? 1, and then what is 1 squared? Yeah, right? So when you plug in -2, you get 1. So obviously -4, 1 is also, right? Because points come in symmetry. Okay, we'll review, all right? So if you're just like, she's going fast, it's okay. All right, so -2, 1, and you got -4, 1, right? There's a reason why I'm marking the points. -1, if I substitute -1 here, what's -1 plus 3? 2. And what's 2 squared? 4. What did I say? -1, 4? And -5, 4. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, and so here's my parabola. And you could do more of them, but I think we're happy with this. So, I'm just recording. Okay, so there is my original function, the given function f of x. Okay, we want to find f of inverse x. And this is also a good thing where, say, Desmos was down this morning. It was perfect because if I'm telling you, if these are the points for the f of x function, and I want the f inverse function, and you haven't been taught yet what the function looks like, but you guys are supposed to know how to solve for it algebraically. Okay, but what if you and your partner are disagreeing on a quiz on what it looks like? Meaning, say Noah solves it and he gets plus or minus rad x minus 3, and then say George solves it and gets plus or minus rad x minus 3. Okay, super easy misunderstanding, super popular, okay? So who's right, who's wrong? Okay, and this is where the first, when you guys really start doing this, the quizzes kind of are low because some of you guys don't realize you can use your points. So even if you think algebraically, you don't know, like, well, what do we do? Which one's right? Because one of them's going to get docked, right? And obviously you have to show proof. Which one? You could still get a beautiful 100% perfect graph. Even if you guys decide to choose this one. This one's wrong, this one's right. Okay, top is right, bottom's wrong. Okay, so what do? Well, if you have your points, which is what I wrote, -5, 4, -4, 1, -3, 0, you guys know from your other assignment, on an inverse function, x becomes y and y becomes x. So for my inverse function points, I have 4, -5, 1, -4, 0, -3, 1, -2, and 4, -1. What is x becomes y, and what is y becomes x. So as long as you're 100% positive of your original function graph, there is no reason for you to get the inverse function graph wrong. As long as you can grab points, you can switch the components. That's it. It's easy, okay? So if I plot it, can I plot it? Yeah. Okay, remember, we're still recording, so. And I hope I don't mess up anything, because that would be terrible. 5. And so my inverse function, wait, can you guys see? Oh, you can't see. Okay. Oh, well, yeah, you can. Okay. So then here's my inverse function. But like we talked about yesterday, I'm going to end up doing the positive side one color and the other side another color. Because remember we talked, remember we talked about the vertical line test? So I'm going to color, if you do one color, you're not going to get docked. But I'm gonna color the top one and the bottom the other, the positive and the negative. No, I didn't record this one. I have to go into decimals. This only records what's under here. It doesn't record if I go to decimals, so I can't record. So I don't record. So yesterday, nothing. Nothing, because I couldn't record. Just today, yeah. Okay, let me continue because I'm still recording. And then I'll stop it, and then I'll pause it, and, oh, actually, no, kind of at the end. Okay, so, look. You're gonna, by the way, it's this one. You end up with y equal plus rad x minus 3, and then y equal negative x minus 3. And the reason why is it has to pass the vertical line test. But if on your paper you have it as one color, you're not docked. It's still beautiful. You're fine. It's just visually, it's my job to kind of show you that this is a function, the green one, the blue one is a function because it passes the vertical lines test. So only one can exist at a time. And so when you write it, when you guys are solving it algebraically, it's totally fine for you guys to write it as plus minus rad x minus 3. That's perfect for the inverse function. Algebraically, you just gotta know that when you're graphing it, they can't coexist and be a function. Okay, not bad, right? So really, what does it come down to? You and your partner better know how to find a function algebraically. That's the hardest part from this. That's it. You got to know how to solve it algebraically because the graph could come out beautifully, perfect, but it's the algebra that gets docked. Right? And that's all your inverse functions. That's your 7th, 8th grade, 9th grade. It's all that math, right? Okay, I'll be quiet. I'll let you guys just kind of 15, 18. Tomorrow I'll do, I don't know, what did I do, 13? So tomorrow I'll do 15 or 18. You guys let me know. We'll go on Desmos. We kind of wrap up this sheet. You're not taking a quiz tomorrow. We'll probably do a quiz on Tuesday. Okay, it's going to be a really long video, so it's going to take a while for it to buffer. Okay, so can I cut it? Yeah. It'll come back up. Just let me